Okay, now let us look at this question. A plane progressive wave is represented by the equation y equal to 20 sine 2 pi t minus 0.5 pi x, where x and y are in meter and time is in second. Find the frequency, the amplitude, the wavelength, the period, velocity of the wave, the maximum velocity of the particle. Good. I want you to pay attention to the unit first. He said that x and y are in meters. Okay, x and y are in meter and time is in second. So what I can say is he given the x and y, they are both in meter. The y is in meter, the x are in meter, and then the time is in second. This is important. Okay. Okay. Before we go further, we must first relate this formula to the general formula. Let me rewrite this formula again. Okay, y equal to 20 sine 2 pi t minus 0.5 pi x. Okay, so what's the general formula again? For progressive wave, y equal to a sine omega t and then plus minus kx. Okay, so write that out. Yeah, write that. The general formula is y equal to a sine omega t plus minus kx. Okay, good. Now compare it with the general formula. So here we have amplitude. Okay, let us. So this is the amplitude, and this is the omega. Okay, this is the omega, and what else? We have the this one, the wave number. Okay, so we have the angular frequency and also the wave number. Omega is 2 pi, wave number is 0.5 pi. Okay, so okay, about the unit, why is it important about the unit? Okay, I want you to write the unit over here also. Your unit for displacement is in meter, x also in meter, your time is in second. Okay, so why is this unit important? Okay, so now look at here. If the displacement y is in meter, so the amplitude also in meter. So they can be cancelled off. Understand or not? They have the same unit. The sign here has no unit because trigonometry here has no unit. Yeah. So the amplitude has the same unit as the displacement. And then for this 2 pi t, okay, 2 pi is the omega. So if time is in second, so 2 pi or the omega must be per second. The unit of this must be per second. Understand or not? Then only can be cancel off. But of course we don't cancel. I just show you that it can be cancelled. And then this what we call the position x. Position x is in meter, so the wave number must be per meter. Must be per meter. Then only they can be cancelled off. Understand or not? So this is important. Okay, but of course we don't cancel. We just want to I just want to show you. Okay, so this is per second, this is per second, this is per meter. All right, so now you got all the units. Okay, another thing is about the sign here. Yeah, the sign here is negative kx. So before that, we already learned, okay, about this formula. If you have a positive kx, means the wave move to what direction? Wave move to left. Wave move to left. If negative kx, wave move to right. Remember this. Okay, positive kx. Normally we say that positive is going to the right, isn't it? To the right direction. But for progressive wave, you just think that it is opposite. It's opposite to what you have learned before. Positive always to the right, but this one, for this case, positive is wave moving to the left. Okay, and if negative, we always say to the left, but this progressive wave, wave is to the right, not to the left. Negative kx means wave move to the right. Okay, so it's opposite to what you have learned before. I just want to make things simple. There's explanation behind this, but I don't want to go into it. Okay, so positive kx, remember positive kx is wave move to the left. Okay, positive kx is wave move to the left. Negative kx is wave move to the right. Just remember this is a bit odd. What I can say, you just think that this is odd. Okay, it's odd. So progressive wave is a bit odd. So the sign is a little bit different. Just never mind. Just remember. So here, this question is using negative kx. Negative kx means the wave is moving to the wave is moving to the right. Wave is moving to the right. Okay, the negative sign here. The negative sign here, it means the negative kx means wave is moving to the right. Just remember that. Okay, so we have done that. Now we want to find frequency. So where can we find frequency? So what I want to tell you is frequency is found in the omega angular frequency. If you know, okay, this frequency, this omega can help us to find the frequency. Okay, later I will show you the formula. Omega can find us the frequency, can find us the period. Okay, and then the K here, K can help us to find wavelength. Can help us to find wavelength. So now look at question A. Look at question A. So how to find frequency? So find from your omega. So your omega is 2 pi f. That's the formula. Omega is 2 pi f, which is also equal to 2 pi. 2 pi. And it is you want to write radian per second, also can. Omega is radian per second. Okay, so from here I can find my frequency. The 2 pi cancel off, and there is my frequency. My frequency is 1 per second, or it is 1 hertz. So that's my answer. Is it correct? Yes, it is 1 hertz. Good. So now how about the next question? The next question about B, the amplitude. Amplitude is the the top, the front part, which is 20 unit meter, because it follows the displacement unit. Okay, so it's 20 meter. So is the answer correct? Yes, it's correct. Okay, now how about the wavelength? Wavelength we can find from where? Okay, just want to write it down. This is the frequency, this is the amplitude, this is the wavelength, this is the period, this is the velocity of the wave, and this is velocity of the particle. Velocity of the particle. Okay, go back to the wavelength. Where can we find the wavelength? We find from the wave number. K is the wave number. So our K is, don't write negative. Negative is just the direction. Is negative. The positive negative here is just the direction of the wave. So this negative is not the value of K. It's not inside the value of K. K is just this value, 0.5 pi. Don't put the negative sign into the K. Okay, so my K is 0.5 pi. So remember, you must always pair up the time with time, x with x. Sometimes it can this 0.5 pi x, it can be in front, and then 2 pi t can be behind. So you must rearrange your formula until you pair up correctly, time with time, x with x. Then only you say this 2 pi is omega, this 0.5 pi is k. You must be careful. So my wave number just now, my wavelength, I can find from my wave number k. My k is 0.5 pi. So that so just write down k is 0.5 pi. Now what's the formula for my k, my wave number? My k is actually 2 pi over lambda. It's actually a ratio. K is actually a ratio between 2 pi over wavelength. Okay. So just substitute inside k 2 pi over lambda 0.5 pi. Okay. Next, let's calculate. Okay, this pi and pi can be cancelled off, and then I got the answer. The wavelength, my wavelength is equal to 4. What's the unit? 4 cm or 4 meter? My wavelength. Just now we know the unit already because it said that x is in meter, right? X is in meter, so the k must be per meter. The k must be per meter. So the k is per meter. Why per meter? Because the lambda is below. Divide by lambda. Divide by lambda. So that's why it's per meter. Write that out. K is actually per meter. Per meter. So meter. That means the lambda here is in meter lah. Okay. Divide by lambda. So meter, lambda is meter. So my lambda is in meter. My lambda is in meter. Is it correct? My lambda. Yes, my wavelength is 4 meter. It's in meter, not centimeter. Good. Okay. That's how you do the question. Okay. Now, how about the period? You know, sometimes he will say, sometimes be careful. He will say, oh, x and y, like this one. Sometimes he say he give you here x and y is in centimeter. He give you x and y in centimeter. So then what happen is this one your amplitude will change to centimeter, and then your lambda also will change to centimeter. So you must be careful with the unit given. Is it the x and y in meter or in centimeter? So it will change the unit for amplitude and wavelength. Okay. Also, the time also very important. Is it in second or millisecond? Sometimes he will say time in millisecond. Then what happened is your period. Later on, your period is in millisecond. Your period will be in millisecond. So be careful with all the units. Okay. So I want to rub that off. Rub this off. Okay. Right now our x and y in meter. So our amplitude and wavelength also in meter. Our time is in second. So our period, this question D, period, also in second, not millisecond. Okay, so continue. So our period, how to find our period? Period is 1 over frequency. Okay, we already got our frequency, 1 hertz. So just substitute that. 1 over 1, so it's 1 second. Why second? Why period is in second? Because your time is in second. So that's why it's 1 second. Okay, it's correct. The answer is correct. 1 second. Good. Next, question E. Question E. Okay, question E. So I want to find the velocity of the wave. How to find? Remember this. Be careful. This is velocity of the wave. Velocity of the wave, not velocity of the particle. Velocity of the wave is, what's the formula for velocity of the wave? Wave speed. Wave speed is v equal to f lambda. V equal to f lambda. Okay. V equal to f lambda. So okay, let's write down the formula. The speed of the wave or velocity of the wave is v equal to f lambda. We have the F already, 1 hertz, isn't it? 1 hertz, and then lambda is 4 meter, right? 4 meter is in meter or centimeter? Meter. So our unit will be in, our velocity of the wave will be 4 meter per second, because the frequency is in, our frequency is in per second, right? Our frequency is in per second. So multiply, you get 4 meter per second. Okay, is the answer correct? Yes, 4 meter per second. That's correct. That's correct. If the question gives the x and y in centimeter, then your amplitude will be in centimeter, your lambda in centimeter. Then your lambda over here also will be in centimeter. Okay, will be in centimeter. So then your speed of wave will be centimeter per second. So must be careful. If centimeter, then all becomes centimeter. You understand or not? Even the speed also in centimeter per second, not meter per second. Okay. Okay. So after that, how about the maximum velocity of the particle? This one is maximum velocity of particle. Particle speed. Particle speed. Particle velocity has is the velocity of particle is always changing. So it has a maximum and minimum value. But velocity of the wave is always constant. It's always constant. It only has one value. It always has one value, which is 4 meter per second all the time. But velocity of the particle, it keep on changing sinusoidally. Changing with, it has a formula, sinusoidal formula. So that's why it has a maximum. Sometimes it's maximum value, sometimes it's minimum value. It will increase and decrease the value. Yeah. So for this max velocity of particle, we have to, how to do? We have to particle vibration. The velocity of particle means the particle vibrational velocity. To find this one, we need to differentiate the displacement formula. Differentiate it against time. Differentiate it against time. So v equal to dy over dt. Like the wave speed is only v equal to f lambda. F lambda, no differentiation. But particle vibrational velocity, we need to differentiate. Then it will have a trigonometry equation. You see that? So we differentiate the y over t, dy over dt. Then we got a omega cos omega t plus minus kx. This is just like simple harmonic motion last time. But for this chapter, we have additional plus minus kx. We have additional plus minus kx. The structure is almost the same. The front is a omega like before. You see that? You see, displacement is a, velocity is a omega maximum. Yeah, acceleration is a omega square maximum. So it's the same as like simple harmonic motion before. Okay, so what is our maximum velocity? What is our maximum velocity of the particle? To get the maximum value, maximum value, maximum particle vibrational velocity is a omega. Particle maximum vibrational velocity is a omega. If acceleration maximum is a omega square, maximum velocity is a omega. So very simple. So this one you just find a omega. Of course, you want to find the particle vibrational velocity, you need to differentiate lah. You need to differentiate, and you get a formula. And then the front formula you will get a omega lah. But for maximum particle vibrational velocity is what? Is a omega, the front part. A omega. Yeah, a omega. Okay. Alright. A omega. So just take your amplitude just now. Your amplitude is 20 meter. Okay, it's 20. The unit also very important. You see, this is meter. You see that? It's in meter. Your omega is, what is your omega? Your omega is what is your omega? Your omega is 2 pi. Your omega is 2 pi. 2 pi. So you will get 40 pi. What's the unit? What's the unit? Just now your A is meter, amplitude is in meter, your omega is 2 pi, and it is per second. You see that? You can write it as radian per second or per second lah. Omega, but the radian can be ignored. They can be ignored. Yeah, because it's not SI unit. So you can ignore the radian. So in the end, your velocity is just meter per second. The unit is meter per second. See that? So that's the answer, 40 pi meter per second. Is it correct? Yes, 40 pi meter per second. That's correct. Okay. So if let's say your x and y in centimeter, then what happens is your amplitude will be in centimeter, your lambda in centimeter, your velocity of the wave also in centimeter per second, your particle, this is the particle vibrational velocity will also be, because your amplitude already in centimeter, yeah, if your amplitude in centimeter, what happens is then your particle vibrational velocity also will end up as centimeter per second. You see that? All becomes centimeter. So you must always pay attention to the unit. Okay? So yeah, so I think that's all. But sometimes it also will give like crazy things, like you say x in meter but y in centimeter. For this time it is x and y both in meter. Sometimes the question will also say x, only the x alone is in meter, y is in centimeter, and time is in second. For this case, what happened is, if y in centimeter, then your amplitude will be in centimeter, and then your x is in meter. That means what happened is your wavelength will be in meter. So it's different. Amplitude is centimeter, lambda is in meter. Yeah, because lambda always follow the x. Lambda is always follow the x. X is in meter, lambda also will be in meter. Just now the lambda always follow the x. X in meter, lambda also in meter. And then the amplitude will follow the displacement, y. If y is in centimeter, then the amplitude also will be in centimeter. Amplitude always follow the displacement. Okay, so be careful with the unit. Okay, this time all x and y in meter. So we can say the amplitude in meter, lambda in meter, velocity of wave in meter per second, particle vibrational velocity also in meter per second. Okay, so that's all for this question. Okay, see you. Bye.